How are you, everybody? Today we will discuss or we will talking about the directional drilling as a fundamental course. The lecture number 1 as introduction. What is the contents of our lecture? Introduction to a directional drilling. Understand the reasons for drilling a directional well. Demonstrate a knowledge of types of assembly used. Planning a directional well path. Development of directional measurement technique use. Development of directional deflection technique use, and understanding the problem associated with directional drilling. Calculation method. Introduction to directional drilling. Number 1, historical development of directional drilling, definition of directional drilling, application of directional drilling, directional well profile. The historical development of directional drilling. In 1930, the first controlled directional well was drilled in Huntington Beach, California, USA. The well was drilled from onshore location into offshore oil sand. In 1934, directional drilling was used to kill a wild whale near Corner, Texas, USA. As a result, directional drilling became established as one way to overcome wild whale. Directional drilling (DD). It is a science as a definition of a directional planning as a directional drilling. It is the science and the art of deviating a wellbore along planned course from a starting surface location to a target surface location, whose location is a given lateral distance and direction from the vertical location. What are directional wells? Directional wells are deviated from vertical straight. That means we will have a horizontal displacement from a vertical location. Directional wells are drilled with international control to hit aboard determined target. Inclination, we have the two angles. The inclination is the angles, and the azimuth is the direction as a horizontal view. When we drilling a directional well, we should think 3D when drilling a directional well. For example, we have here the vertical side, and after that we have the angle here, alpha, the inclination angle. From the vertical side to this point, we can call the horizontal displacement. And from the horizontal view, we have the angle from the north side, north, south, east, west. This beta angle, azimuth angle. This is called the direction. The inclination angle is the angle measured from vertical to the axis of Z accelerometer. This is the vertical side, and the inclination angle alpha or survey point, it is the horizontal displacement from the vertical side, and this is the target. Azimuth angle, from the horizontal view, when we look from up to down, we need to know the direction of the well or direction of the target of the well. If we have the directional drilling, we first drill the vertical side or vertical stage, and after that we should take the angle of inclination as a planned 20 degrees or less than from the vertical side. But azimuth, it is the direction to, for example, north. From north, we start from 0 degrees to 90 degrees east, and south 180 degrees and 27 west degrees. If we have 20 degrees north to east, that means the direction will be in this side. So we should know direction of our target and the well from the vertical and horizontal view. Types of a well. Wells are generally classified as exploration wells, whale, cat well. These wells probe the earth where no known hydrocarbon exists to determine whether oil or gas are present in a subsurface rock formation as exploration wells. Appraisal wells, they are drilled to determine the extent of a field or the amount of area it covers. Development wells or production wells, they are drilled in an existing field to remove the hydrocarbon or to bring the hydrocarbon to the surface. Application of directional drilling. Number 2, inaccessible locations, like well drilled under a mountains, if we have a mountains, or if we have sensitive population area like the city or the houses. Under these houses or under the cities, we have the reservoir or the hydrocarbon. So we should think to drill a directional or a horizontal well in this side, such as beneath cities, sea or lake or river beds, planets, mountains, roads. Sidetrack wells, application of directional drilling. Number 2, sidetracking was the original directional drilling technique used to get past fish, obstruction, and obstructions in the path of the wellbore. Vault. Number 3, vault controlling. If we have the vault in this formation or where we will drill the well. Vault controlling is an application used to drill a directional wells into vaulted subsurface formation without crossing the vault line. It is a parallel or a perpendicular to a vault plan, like this or this. To be perpendicular and not horizontal or perpendicular. Salt dome drilling. If we have offshore, if we will drill in offshore well or inshore. If we have the salt dome and here the traps of hydrocarbon like this or this or this. Salt dome have been found to be natural traps of hydrocarbons. It's, as we know, accumulating beneath the overhanging hard cap. Number 5, onshore drilling to offshore location. From this the sea, from the onshore location to the offshore location where the target or the reservoir. Onshore drilling takes place when a reservoir is located below large bodies of water that are within drilling reach of land. The well Number 6, relief well. Relief wells are used to kill wells that are boiling by intercepting the borehole. Application of directional drilling. Number 7, multilateral wells. Multilateral wells, as we see here or there, might be 1, 2, 3, multilateral, not less than 2 lateral or 2 reservoir. Multilateral wells have several well bores running laterally and originating from one original hole, from one conductor or surface casing. Multi-well exploration wells from a single well bore. From a single well bore to multi-well exploration wells. If we have a mistake or drilled a dry well, we can retry to open the window from the casing to the second reservoir to get the target. Offshore multi-well drilling. Offshore, from the offshore, we know that in offshore drilling, this is very expensive, and we should be thinking economic to drill a wells or more than one well from one side or from one string of casing to be economic our field. Offshore multi-well drilling is the most economical way to develop offshore field, to be developing the offshore fields. Several directional wells are drilled in clusters on a multi-well offshore platform. From one platform, we can drill more than 3, 4, 5 to 50 wells. Horizontal wells. Horizontal wells are used to intersect a producing formation horizontally to better produce the reservoir. If we have the reservoir or the thickness of the formation of reservoir is small, we should be thinking to drill a horizontal well to get more hydrocarbon from the reservoir. Short, medium, and long radius wells. When we will use or we will to drill a horizontal well, we should know the short radius and medium radius and long radius for every well or every horizontal well. Short radius wells, typically re-entries of old vertical wells, have curves with 143 feet or 44 meters radius as a radius for the short. But for the medium horizontal well, it is from 200 feet to 500 feet. For long, it is more than or equals 75 feet radius. Extended reach wells. Extended reach wells are drilled to reach reservoirs that have a horizontal displacement more than 5,000 meters from the starting point, from the surface or from the starting point to the 5,000 meters. Directional wells profile. It is the planned well trajectory from the surface to the final drilling depth or to the target by projecting the wellbore into two plotted plans. The objective of any directional wells profile is to provide the safest and easiest path from the surface location to the target location. Types of directional wells. We have more than 3 or 4 directional wells. Number 1, the build and hold angle. First, we drill the vertical section. Excuse me. The first step of the directional profile tips is the build and hold profile. Build and hold application at tab 1. well is drilled vertically from the surface. We should drill the vertical section from the surface to the target of the vertical section and or to the kickoff point. Kickoff point, it is the start of build-up rate. The build-up rate, it is the should have the inclination angle here from the vertical side to the end of build-up rate. And after that we will the third section, hold angle and tangent section. We should go straight the directional to the target of the well. To the target of the well. And from the vertical side to the target we have the horizontal displacement target deflection. We can call the target deflection. So it is the first profile tape of the second tape of the profile. It is the G tape or G type. It is the vertical section and vertical section from the surface and kickoff point, start of build up or start of to take the angle of inclination and build up the rate section to the target where the reservoir or the hydrocarbon. End of build rate, start of build rate or kickoff point and horizontal displacement target deflection. This tape will called G curve, and this tape too well is a continue build target. It is similar to tape well expected the kickoff point is at deeper depth. Look at the view from the surface location to the kickoff point, it is the deeper or the vertical depth is high and the surface casing is set superior to the deflection the well. The surface casing should be the deflection to the and inclination is continually built through the target interval and it is not used very often like this profile. For deeper depth drilling, for bowl drilling, for multiple sand zones, for high inclination angle, for salt dome drilling, and for low lateral displacement. Disadvantage of this profile: formation might be harder, so initial deflection might be more difficult. Harder to achieve tall face orientation with downhole motor deflection assemblies. More reactive torque. Longer trip time for BHA bottom hole assembly change. The third tape is the S-tape profile of directional well. S-tape application, the tape tree well is often called an S-curve. It is similar to the tape 1 because the well is deflected at relative shallow depth. The angle and direction, the angle of inclination and the direction of the target are maintained until a specified depth and horizontal departure has been reached. Then the angle is steadily and smoothly dropped until the well is near vertical, like this. Vertical section to the kickoff point from the surface location, and the second section is the build rate or from the kickoff point to the end of build rate. And end of build rate, it is the same start of drop down angle. This build rate angle and drop down angle to the target of reservoir or our reservoir. Horizontal displacement it is the target deflection from the vertical side from the surface location. The fourth type of horizontal tape profile. Horizontal tape application, the tape number 4. Wells can be categorized as horizontal or extended reach wells. Design of these wells can vary significantly, but they will have high inclination and large horizontal departure. Used to isolate higher or lower pressure production zone. We have some zones with higher pressure and higher temperature. So we use this profile to isolate higher or lower pressure production zone or water sand without setting a cementing liner, without the liner or cementing this casing liner. Horizontal wells will have an inclination greater than 80 degrees. Like here, it is the long side of the vertical section to the kickoff point, and after kickoff point we start to the build angle section with inclination angle to the end of plan profile. After that we start the horizontal section from this end of build angle to the target of our reservoir, and from the vertical to this target we have the long horizontal displacement or target deflection. The type of horizontal profile, as we said previous, we have the true short radius and medium radius and long radius for every target, as we have the depth of the well. Planning a directional well path. Kickoff point, build up rate, azimuth direction to know the direction from the north side from the horizontal view, and inclination angle from the vertical side, the inclination angle, and true vertical depth is the true vertical depth, and we have the measured depth as we saw here, as shown here, from surface location to kickoff point to this point to the target. It is the measured depth, and we know the measured depth is longer than the true vertical depth. From this side to this side, it is short from this side to the end of the side, our target here. And horizontal displacement, it is the deflection from the vertical side. And the azimuth direction, as we know, it is the direction from the north to the east or south or west. Deviation or departure calculation. We can calculate the deviation of this horizontal displacement. Deviation is defined as departure of the wellbore from the vertical side measured by the horizontal distance from the location, from the rotary table to the target. The amount of deviation is a function of drift angle inclination and hole depth. The following diagram illustrates how to determine the deviation or departure space. AB, from A to B, it is the vertical section. Kickoff point, it is the when we take the inclination angle, and BC, from B to C, it is the vertical BC, it is the distance from kickoff point to the true vertical depth of the well, from here to here. And BD, it is the BD, it is distance from the kickoff point to the bottom of the hole, measured depth. It is longer than the true vertical depth. CD, it is the horizontal displacement from the vertical side of surface location of our well to the target or of reservoir. I inclination angle, it is the inclination angle here, and AC, A to C, it is the true vertical depth, and ABD, it is the measured depth. To calculate the deviation or departure CD, to calculate this distance, we should take the triangular CD feet, it is the sine of CD, this distance, it is the sine of this angle inclination, multiplied by BD multiplied by this line. Planning a directional well. What are the opinions that should be taken into mind during planning for a directional well? We should be clever when we thinking. Well depth, we should know the well depth of our target, horizontal displacement from the vertical side, horizontal displacement, and well casing point where we will do the casing or for the all stage of the drilling. The maximum build and or drop rates for the angle, maximum angle for the build or drop if we have the drop angle. The maximum average angle of inclination, formation type, what we have, hard, soft formation, we should know, depths and expected rate of penetration, ROP, rate of penetration of our drilling in this formation, mud weight, mud temperature, and mud tape. Number 8, well histories, logs, directions, and direction tendencies in the area. So our lecture of directional drilling is finished. Thank you. We will continue the second lecture in the next time. Goodbye. Thank you for all.